Hey everyone, we're going to use the principle of mathematical induction to prove that 6 to the n power minus 2 to the n power is divisible by 4 for all positive integers n. And we're going to use these steps here for mathematical induction. And we're going to also use a definition of divisibility to help us write it. So S sub n represents the conjecture using the definition of divisibility. I can't say it. So we have x, 6 to the nth power minus 2 to the nth power equals 4r. So that's our definition of divisibility. And that's for some r that's an integer. So an integer that equals r. Now we're going to verify first that it works for n equal 1. Now 4 is divisible by 4, so this is valid for n equal 1. Now we're going to go to this step and assume that S sub k is true. So that means it's valid for n equal k. So we're going to write it as 6 to the k power minus 2 to the k power equals 4r. And that's for some integer r. All right. And then we're going to show or prove that S sub k plus 1 follows. So that means 6 to the k plus 1 minus 2 to the k plus 1 equals 4t. We're going to have to change that. So this is for some integer t. We'll get into this a little later. But what we want to do now is to start with this one and make it look like this one. So the first thing I want to do is rewrite it to help me to do that. So I'm going to start it up here. I have S sub k equals 6 to little k minus 2 to the k equals 4r. And the r is the integer. And then S sub k plus 1 equals this, 6 to the k plus 1 minus 2 to the k plus 1. And now we want to change this to t for integer t. All right, now we're going to rewrite this one. And we want it to look like this one at the end. And then we have proved that it works. So let's go ahead and subtract this from both sides. So we're going to write 6 to the k power equals 2k plus 4r. All right. Now, to make it look like this, I'm going to multiply both sides by 6. I forgot to multiply by 6. So times 6. That's to the first power. And then I'm going to do 2 to the k power plus 4r times 6. But instead of write 6 here, my 6 is going to be 2 plus 4. Because that equals 6. And then I'm going to use the distributive property to simplify this. So basically this part here, if you condense it with exponents, it's going to be 6 to the k plus 1, which is what we wanted. All right. Now on this part, when you distribute this out, you're going to get 2k times 2 is 2k times 2 to the first power. That's just going to be 2 to the k plus 1. And the rest is going to be plus 4 times 2 to the little k plus 8r plus 16r. Now, let's move this guy back over. And we have 6 to the k plus 1 minus 2 to the k plus 1 equals, and what I want to do on this side, is, first of all, this equals 24r. So let's write that out, 24r. And so on this side, I'm going to factor out a 4. So this is going to be 4 times 2 to the little k plus 24r. So let me write it on this side. So we have 6 to the k plus 1 minus 2 to the k plus 1 equals, now factor out a 4 and you're going to get 2 to the k plus 6r. And recall that we had, this was really 4 times 2 to the k power plus 24r. So I just factored out the 4 out of that. Now I'm going to call this t, and that's why I changed the other one to t. So this is going to be t equals 2k to the k power plus 6r. So rewriting this, I have 6 to the k plus 1 minus 2 to the k plus 1 equals 4t, which equals our s to the k plus 1. So it follows. And since s of k is valid, then s of k plus 1 is valid. All right? So it works for n equals 1, equals 2, equals 3, and so forth. So it's divisible by 4 for all positive integers n. That's it. Thank you. Have a nice day. Bye-bye.